I have some interesting slides that I have put together for you to give you an overview. First of all, we'll start with the basic set of services in the serverless space, and then I'll also give you a glimpse of some of the advanced features that we have introduced. So before we get started, I would request you to keep posting your questions. We'll collect all of those. And just to make sure I answer all of your queries, I'll go through my presentation. And then at the end of it, I think I'll just go through all comments that you guys have posted. And then I'll try my level best to answer all of the questions as time permits. So yeah, with the housekeeping out of the way, welcome all of you. And thanks for giving AWS and especially me this opportunity to talk on this particular topic. And I appreciate the fact that you have taken some time out from your busy schedules, considering it's a weekday, to join us. So I hope I'll be able to do justice to the topic, and I'm sure I will. Looking forward to having some interesting conversations on that. So with that, let's get into the let's enter the serverless land. So I'm sure the title is a little catchy there. That's not on purpose. The idea was just to make sure I went through this journey myself, because sometimes without having a good understanding of what serverless means, it feels like it's an enigma, right? So serverless, as most of you might have already gathered by now, doesn't mean there are no servers. It's just that the management, the upkeep, and the operational part of that is handed over to somebody else, which frees up time for you as builders to build without worrying about the operational aspects, and that provides you a lot of other facilities and capabilities. I'll touch upon those as we go along. So let's move to the next slide. What I'm going to talk about today is the trends that we are seeing in the market and why we are seeing customers adopting a serverless first strategy. Having said that, we at AWS know that a lot of customers are in different phases of their journey towards the cloud, and not everybody is starting afresh or not launching a company today, right? So there are enterprises, there are organizations that are having a lot of applications that they have built over the years, and it's not easy for them to just rip and replace everything just because we have come up with a new technology. So we see customers going through multiple different stages as far as their adoption of serverless is concerned. And the second part of my talk today is going to touch upon some of the different paths that the customers we see taking when it comes to serverless. So building new applications, as you can imagine, is a natural step for anybody who wants to start serverless development. And that's the best possible thing, because then you have all the tooling at your disposal and you don't have any kind of technical debt that you need to worry about. But like I said, some of the customers still fall into the other two categories, the replatforming and refactoring. And I'll talk about those, what it means for any customer, as well as you guys who are joining us today. If you are representing customers or if you are working for customers and implementing AWS solutions, what does it mean? So what do our customers need to drive success, right? So these are some of the high level themes that typically we see, and that lets them innovate quickly, and that helps them compete in the global market. So as we have seen, because of the advent of internet, access to some of the services has become easier, which means new business models get created, they get tried out. And for you to quickly try out and quickly move on to a new idea, if something doesn't click, you don't want the baggage of configuring everything, setting everything up, and then finding out that things didn't work. So the technology aspect of it, as much as becomes a background activity and doesn't need to become a necessary task for any company or anybody to perform first before they can actually deliver any business value, the more easier it is, the barrier to entry becomes a lot less. So the customers want their teams to deliver products to their customers as fast as possible, which is what we talk about when we say getting to the market faster and quicker. They also want the applications and infrastructure to be reliable, highly available, and scalable, which means the lesser you have to worry about patching things up or getting the page at odd hours, you are more focused on creating that additional value for your customers. They also want it to be having highest security and isolation. Um, for us at AWS, security is job zero, as we say. So anything that we build, we always want it to be absolutely secure. And that's a shared responsibility that we share with our customers. So there is a part that we take care of, and then there is a part that we expect our customers to also take into account when they build their applications on our platform. And then all of this they typically want with a lower cost of ownership. So this is where I think most of our customers we have seen wanting from any cloud platform. One of the things that we keep hearing from our customers and their C levels is what is the biggest barrier, you think, right? So biggest barrier for them is a lack of time spent on what matters. And what I mean by that is they would want their developers and their operations team to focus on innovation and want to move with speed. But they most of the times at large organizations, especially those who already have a lot of install base, the developers have to spend a lot of time in the upkeep, like we say, the keeping the lights on activities, right? So they spend a lot of time in the operations and maintenance. So we want to turn that around, and that's where serverless adoption is growing fast. And this is where serverless shines, in my opinion, because serverless strategy enables our customers to focus on things that benefit their customers and not worry about the infrastructure management. So we launched an example of this is I think most of you, those who have attended some of these sessions might have heard some of my other colleagues talking about a technology called Lambda, right? That is what the whole serverless um, movement start with that. So we launched the Lambda service about close to about 6 years ago, and today we have thousands of customers who have built applications that already drive trillions of invocations per month on our platform, right? And it continues to grow at a phenomenal rate. So these are some of the statistics that I wanted to put in front of you guys just to appreciate how much difference the serverless technologies have made for our customers. Now, naturally, you would ask, why are customers building with a serverless first strategy, right? So the reasons are the customers are adopting serverless strategy are aligned with what the customers are looking for. And these are also the areas where we put most of our investment, right? So AWS is fortunate to have hundreds and thousands of years of engineering experience collectively across all our engineers who have been continuously adding new features to our platform over the last 15 years. And they have that experience of building applications in the cloud, which comes in handy when we introduce new features on our platform. And we use all of that experience to bake into our services the lessons we have learned about building in the cloud. Most anecdotal example could be Amazon.com, which has gone through a lot of different phases throughout its 15 plus years of journey, which some of you who have interacted with our Amazon.com website would have witnessed that. There are 4 key areas where we are always innovating to try to provide those simple and powerful capabilities. One of them that is agility, which is what our customers are demanding for the developers and operators to move fast in this space, right? Then the performance aspect you cannot overlook. So performance to support as many workloads as possible, and also making sure you have built-in security mechanisms and we keep improving continuously. And then at the end of that, all of that at a lower cost and with a pay-per-use model. So to help appreciate some of that, I want to cite an example of a customer, and this is a customer case study that you can go and read about on our website as well. So Coca-Cola is a great example of how serverless strategy enabled agility when they had to react quickly to the changes brought on by the COVID pandemic. So they have this product that they call freestyle drink dispenser, the one that you are seeing here in the image. So it used to be you see the screen over there where a customer could interact with and essentially get a drink dispensed. But with COVID and with all the restrictions about uh, not wanting to or avoiding as much touch possible, what we did and what Coca-Cola did on our platform is built a mobile application, which through that application the customers can order and pay for drinks, as we call it a mobile pour application. Because of that, they built uh, uh, this particular application using Lambda, and their team was able to focus on the application rather than the security and the latency or the scalability, because all of that was taken care of for them by AWS. And this is where, again, with serverless, you can, as we say, hand over the heavy, undifferentiated lifting to us so that you can focus on building the applications. So they have already they were able to build this application using serverless technologies in 100 days, and it's already been integrated with 30,000 machines, which are now having a touchless capability. So you can just order the drinks using your app. So how are customers adopting a serverless strategy? Again, if some of you have attended some of our sessions, maybe my colleagues have already touched upon this, and you might be aware of the concept of 6R strategy, right? What we call 6 different R's of how you typically start your journey on cloud platforms. So one naturally is you can start afresh and build a new application from scratch. But when it comes to your existing portfolio, you have a few options, and not all of them will involve a serverless outcome. So let's see what those are, right? So on the far left, you see a reduce strategy, which means the customers focus on reducing by either retiring their applications, or they do a replacement by going and buying a SaaS product for an existing version of their product that they have been running in their on-premises setup. So that's the leftmost version of what you can do as far as your existing applications are concerned. Then we come to lift and shift, which is migrate to AWS, and most customers benefit from doing this quickly to get out of their data center management and come to a common environment where they can start innovating, because then a lot of services become available to them, which they can benefit from. And then to your far right, if you see where you start modernizing. And when it comes to modernizing, you can replatform or refactor. And as I had mentioned at the start of my talk today, these are the two strategies we'll focus more on. And I will talk about how serverless and some of the serverless services or products that we offer in this space will help you achieve that and do the replatforming and refactoring of your applications. When we say replatform and refactor, there is a subtle difference. Replatforming essentially would mean moving from a service you manage yourself to a service that AWS can manage for you. So an example could be moving to a managed database, or moving from a self-managed RabbitMQ to adopting Amazon MQ, which is a managed version of the same service. And finally, the refactoring. I understand, and I think all of us who are on the call today appreciate the fact that refactoring sometimes takes longer effort to achieve the intended result, but then it sets you up in the right direction to further enhance and build those capabilities on your applications. So finally, refactoring is where customers see the biggest transformation, because successful customers, they start by refactoring their most business critical or customer facing applications, because that's where they'll get most time to market and TCO benefit, right? So there are certain patterns that also I'm going to talk about today that help in refactoring, and how that will also shorten some of the cycles. So let's start with the first topic, which is building new applications. Typically, what we see is we see our customers building a wide variety of applications with serverless building blocks, but there are a few common areas where they tend to see huge benefits. So generally, we see that IT automation is where most of our customers will start their journey with trying out some of our serverless technologies. Um, we in AWS jokingly say that Lambda is our gluing technology, right? For anything that is not out of the box, you can always quickly write a Lambda function and bridge that gap. So if a particular set of services don't talk out of the box with another set of services, Lambda is always there to help you. So Lambda always comes to your rescue when such instances are there. Next, individual teams will start using those Lambda integrations with S3 or with Kinesis streams to build data processing applications. And then as experience spreads throughout the organization, multiple teams, they start building whole microservices based application. Now I've touched upon a very important uh, term here, which I guess I might have again got a lot of you interested, microservices, right? So serverless and microservices go hand in hand. Serverless technologies enable a lot of microservices based development. I will also talk about another term that you might have come across as we go along through this talk, which is DevOps. So the dev and ops are essentially, we're trying to merge the divide or the gap between those two um, uh, departments, and essentially how serverless allows you to do that is what I'm also going to talk about as we go along. And then finally, as the maturity curve in the maturity curve for the organization, as they get more comfortable with the technologies, then they start dabbling into the machine learning applications. So as they start creating a lot of ingesting a lot of data, then they start actually using that data to make predictions. So if you have gone on our management console and have taken a look at some of the services that we offer, one thing you will see common across all the serverless applications is they follow a design idea of the internet and web. What I mean by that is small pieces and they are loosely joined, right? So all of these applications are very modular, composed from multiple AWS services. As you see here on the screen right now, on the left hand side, you see a lot of icons that represent a lot of such services in the serverless domain. And that is why we are focused on delivering lots of integrations in Lambda and Event Bridge and API Gateway and step functions. So I will double click on each of these icons and I'll talk about what purpose they serve. But I just wanted to give you in one place an idea of what serverless portfolio for AWS means. Now, uh, in the interest of full disclosure, I'm sure there are a lot of other managed services that you must have come across on the AWS platform. One famous could be Kinesis. It's also a serverless service, and but because it is generally driven towards the data analytics or data processing space, it doesn't factor into the overall. Uh, though it is a serverless service, that is something that I'll not be touching upon today. In a maybe another session, I'll take some of the other serverless services that touch different domains, be it data analytics, be it security, for example, Cognito. For example, some of you might have come across our Amplify stack of services, which essentially, again, a lot of serverless components are into that. But those we can keep for a discussion for another day. Today, we are going to focus on most of the icons that you see here on the screen, and I'll talk about each of those. Typically, the journey starts with APIs that are managed by API Gateway as the application front door. And often events or messages, they become the communication system in the backend, right? All coordinated with workflows. So as you can see here on the right-hand side, a typical example of how your front-ending applications, be it a web app or or a mobile app, how they interact with some of our services and how the flow of information, flow of data happens. While many customers associate serverless only with Lambda, there are actually serverless services at all layers of the stack. And that is why I wanted to put this slide here to give you an overview of each of those areas, be it compute, be it data storage layer, or be it integration layer. There are many services that just that go beyond just the Lambda, right? While Lambda offers many key advantages, it's really when all these other components surrounding Lambda that we start to see much bigger benefits. So messaging, orchestration, storage, compute, when it is put together, is actually the secret sauce for building a full-fledged serverless application. But in fact, it's really when all of these components come together, like I said, you start seeing big gains or big advantages. So let's start with the compute first. For many customers, their first decision when it comes to application architecture is compute, right? So as you can see here on this particular slide, there are four different layers or four different offerings that we have in different layers. You can start at the very bottom with EC2, where you have access to all the knobs that you want to manage, or you could go completely serverless, which is the topmost layer here in the stack, with Lambda, where you are focusing just on your application. And most of the, as I said earlier, the heavy load lifting is handed over to us. So the layers of abstraction available to you with AWS is very empowering because your teams have the choice to pick the layer of abstraction they are most comfortable with. And that's why we give you coverage across each of these areas. As you can see on the left hand side with an arrow, the once you start moving up or down on this stack is where the management aspect of it becomes either more taken care by you or less taken care by you, right? So that's how, depending on where you are, which particular service you're using, you would be either managing more or managing less as far as the infrastructure is concerned. Now, entering the world of APIs. APIs typically are one of the primary mechanisms through which these small pieces or services, they communicate with each other, right? So that's why we call them the front door of your microservices. Many of you might have already used some of the serverless technologies. API gateway factors into this primarily, and that becomes your entry point into the world of serverless for your consumers most of the times. So let's consider an example how we use APIs at Amazon, right? So the first thing any team within Amazon, if they are building a new API, they go and check if a similar one exists. And I think the similar analogy can happen at a customer, right? When you want to build a new API, you typically want to go and check in a central place or some kind of a registry or a repository if an API already exists. So that means it makes APIs like a phone book for your microservices. It gives you a pretty organized view of your microservices architectures so that you don't create duplicate services or duplicate APIs. So typically APIs is where you would start your journey into serverless. So I've put here a sample architecture for your reference, wherein you see mobile apps and websites where you have deployed your applications and your customers are using those applications, interacting with them, would essentially come in through the Amazon CloudFront, which is our edge service for giving that API access as close to your customer as possible to avoid the latency issues, right? Once you enter the API gateway, through the API gateway, you have access to a lot of API gateway cache, which essentially allows you to not even do a round trip to your backend and serve some of the frequently accessed content, which doesn't change much through your cache. So that is something that we make available to you as part of the API gateway offering as a product, right? So that you have access to that cache, which allows you to quickly respond to your customer and make that experience better for them. It also has a inbuilt integration with the CloudWatch monitoring, which essentially allows you to monitor each and every API call for further um, analysis. So you can look for any suspicious trends or if there are any dashboards you want to create upon how your API adoption is happening. CloudWatch monitoring can help you with that. Then you can integrate your API gateway directly with Lambda functions. That is an out-of-the-box integration that is available for you, as well as with a NoSQL database like DynamoDB, you can make it as a backend for your API gateway to directly talk to the DynamoDB to store certain records. So that kind of out-of-the-box integration will help you when it comes to the API gateway. The second common integration pattern that we see is through use of events. And those who have maybe implemented a few microservices architectures would have come across this concept of event management or event orchestration, right? Because when you start distributing your application into smaller pieces, the microservices, they need to have a mechanism to interact with each other. And that is how, through events, is how they start interacting with each other, which are changes of state or updates. So, an example of an event could be an item being placed in a shopping cart on an e commerce website, or a change in status of a support ticket, right? It could be an event. Event is something that has happened in particular application, and then you um, publish that event. So event-driven architectures can improve your scalability, your fault tolerance, and agility by reducing dependency between processes and teams. So what typically would you see in an event-driven architecture, right? So as you can imagine, events by nature are very asynchronous. And what I mean by that is you don't need to wait to get a response to move on to the next step. So you can immediately just fire an event. It's what we call fire and forget pattern, and you can move on to do your next set of activities. This improves the resilience and reduces coupling and dependencies, as you can imagine, because you are not waiting for a response. Your code can go and, or your program can then start serving, or start going through the next steps. The tools of event-driven architecture are typically routers, as you see here on the left-hand side, that abstract producers and consumers. So they basically create this loose coupling. So both parties, the producers and consumers, don't need to have any knowledge of each other. So you can publish to the router or you can consume from it without the knowledge of a producer or consumer. As long as you are interested in a particular event, the event router will make sure that it gets either delivered to you, or you can poll the event router and get that. So there are these polling and pushing, essentially patterns that come into picture when it comes to the consumption part. Event stores, they act as buffers. Those who have done some integration projects might have seen or might have used queuing technologies, where holding on to events until the consumer is ready to use them. So you can store those events for a temporary purpose. And again, typically we don't store those events for life. If they need to be persisted further or beyond a certain point in time, then database is your best friend there, right? So you typically persist such events for further analysis, into a permanent storage. This is typically considered still as a temporary storage, but it is used for a reason where if a particular party, be it a producer or a consumer not being available, doesn't break your flow, so you can continue to operate. And that gives you more resilience because of the loose coupled nature of the pattern. So it uses standard API protocols like JMS, NMS, and again, those who have implemented some queuing solutions would have come across these. Most of the time, we talk about events coming from AWS services, but we also know that nearly every business uses some kind of SaaS application. Maybe it's Zendesk, MongoDB, or Datadog, and you might have come across some of these in your environments. So in 2019, we created a third-party integration program starting with Event Bridge. So Event Bridge is our event router here, a serverless event bus we call, and that's the Event Bridge. So with this capability, you can use data from any of the supported SaaS applications, the ones that you are seeing on the left-hand side of this of your screen, and those can actually publish to a specific event bus that is created within the Event Bridge product called SaaS Event Bus. So you can integrate these SaaS event sources, and through those, you can publish your events into the SaaS Event Bus, which can then further be consumed by your event targets. So we also recently launched another integration tool, which is called Amazon App Flow. I'll share a link to that if you are interested in taking a further look into what that offers, but which offers a no-code user interface through which you can bring in data from SaaS applications like Salesforce. So it comes up with pre-packaged kind of solutions where you can integrate these SaaS platforms and consume data from them. So that's another product that typically our customers use. Now all this is great, right? We talked about asynchronous way of operating. We talked about microservices, but decoupling is at the heart of all this, right? And finally, we'll talk about where we'll be storing state, because by now you might have realized that if I talk about serverless, that means I don't have access to any specific server, then where do I store my state, right? So in a traditional application, you will be storing the state of your application into the server itself. But in a serverless model, you don't have access to that server because that's been managed for you by someone. So then you have typically two options. If you prefer to run your business logic in containers, then you can use Fargate, which is another serverless service that we offer in the compute space. If you had noticed that when I showed the compute pyramid, right? And if you prefer to use Lambda, then you can store the state in another product that we call step functions. Step functions are basically a state machine that also enables you to design and run workflows that stitch together services such as AWS Lambda, AWS Fargate, Amazon SageMaker, which is our ML service, machine learning service, into a feature-rich set of applications. So one such example that I want to show you here is where you have a client that is posting a set of information through the form data onto an Amazon API gateway. So Amazon API Gateway is a serverless component where you have deployed your API. You can immediately respond to your client saying you received the event, and then you publish it asynchronously to your step functions workflow, which essentially then starts executing steps one by one. It's a pretty common modern cloud application pattern that we see across customers. This is where your managed workflows can be very helpful. They let you focus on defining the component interactions, because think of a case where if you had to write this from scratch, you not only have to write the specific logic, but you also have to write all the plumbing logic. What I mean by that is from detect sentiment to generate ref, if there is to be a call made, then you have to write all that into your code. So with step functions, you can just create these as different steps and integrate those with Lambda functions or additional external serverless services like Amazon Comprehend that I've shown here, and Amazon Simple email service, which is another serverless or a managed service that you can integrate into the step functions workflow. So the whole state management is provided to you by step functions, and you can just bring in your logic and then just stitch it together, right? So that's how we typically see our customers doing certain things. So now moving on to the next step of our journey, right? So this was more of a view into what our serverless products, some of our serverless products and serverless technologies are concerned. They are very well equipped to handle the scenario of a building from scratch. So you can start writing Lambda functions from scratch. You can start writing your APIs or build your APIs on your API gateway platform. But like I said, some of the customers can't fit into that mold of writing from scratch. So typically for them, we have an option of either re-platforming or a uh, refactoring, right? So let's touch upon the re-platform aspect of that first. So re-platforming for us, we typically say is what we call lift tinker. By tinker, I mean just modify a little for it to be suitable for executing on a cloud environment and then shift it. So re-platforming still allows you to and makes you shift into a cloud environment, but in that process, you end up tweaking certain aspects of your application so that it becomes cloud native or cloud ready. And what I mean by cloud ready is to benefit from a lot of features that cloud technologies provide, be it scalability, be it security, be it reliability, right? So replatforming example could be, instead of managing your own message broker, you can migrate into an Amazon MQ, which is a managed offering that we have on our platform, and leveraging your current monitoring tools with AWS Lambda. So to give you two such examples, I, I will what I will do is there are detailed blogs that are written by some of our Amazonian colleagues. I will attach those and I'll share those at the end of this session for you to go and have further read on that. But these have become real game changers for us because, as you can imagine, with serverless, sometimes you don't have access to the actual server, right? And also you don't have control over how the runtime will behave. All you can do is code, and that gets executed behind the scenes for you. So we have done through some extensions and container image support. We have increased the adoption. We have tried increasing the adoption of Lambda so that you can integrate with your existing set of tooling. So we know that customers want to standardize on one set of operational tooling, as well as some of the customers start their journey from EC2, they move on to the containers. And before entering the serverless space, they want to just try out if the tooling that they have put in place, be it a CI/CD pipeline, continuous integration, continuous deployment pipeline, they would want to see if there is a way to get into the space of serverless, but not letting go of their existing investment into building some of the necessary foundational components, right? So for such customers, we have introduced a feature called Lambda container image support. Our goal here was simple, right? So we wanted to give our customers the best of both worlds. What I mean by that is easier packaging that comes along with containers, as well as Lambda's 140 plus native service integration. So through Lambda container image support, what you can do is you can package your Lambda function and package it inside a container and deploy it. So some of the scaling aspects, some of the advantages of container technology is made available to you. At the same time, only focusing on your business logic and not worrying about other aspects of your operational um, aspects is handled by Lambda for you, right? So that kind of gives you best of both worlds. But it is not as simple as just supporting the OCI format, right? So along with support for OCI images, what I mean by that is we support standard runtimes like Node.js, like Python. But at the same time, we have added support for up to 10 GB package sizes. And we have also open sourced some of our base images on top of which you can write your own supported language runtimes, and you can create a customized image which you can deploy inside inside your container. Part of why we wanted to talk about extensions and container image is because we are very happy with the uptake, and a lot of customers have adopted this and have benefited from it. So the second part of it is Lambda extensions, right? So what happens with Lambda extensions is essentially uh, you have seen, and you must have also, some of you who have already deployed applications, maybe on premises or inside AWS, the observability. And what I mean by that is getting to know how your code or how your application is behaving is a very important aspect, because that acts as a feedback mechanism for you to do any further improvements, right? So any application building exercise is not just once done and forgotten, right? So you have to always keep monitoring it. You have to, based on the monitoring, based on the data provided by the monitoring tools, you would want to incorporate the changes into your application and create a newer version of it, a better version of it, right? So with Lambda, what happened was customers always said that Lambda is really good. It takes away a lot of heavy load lifting from us, but it still feels like we can't use some of our existing tooling for using the extensions, right? So can we integrate our existing monitoring tools to work with your Lambda service? So Lambda extensions is designed to support the tools you already use today. So some of the names that you might have seen on this slide are maybe familiar for you, like HashiCorp, Datadog. These are some of the existing um, tools that most of our customers are already using to do a detailed monitoring of some of their applications. So with extensions, what we have done is we have worked with some of these extension partners. What they have done is they have built those extensions using the extensions API, which essentially runs on top of our Lambda runtime API, but allows you to plug in your existing monitoring tools to monitor the Lambda executions and the Lambda functions. So we are very happy with, again, the adoption of the extensions API. Both the container support and the extensions API were introduced around 2020. You might have heard, those who might have attended the reInvent might have seen these announcements. So they are seeing a very good adoption of that. So these are two specific Lambda related uh, additions that we have made, which allows the replatforming or makes the replatforming easy. Some other examples could be Amazon MQ that now supports RabbitMQ along with Apache MQ, that we have also added that support. And you can also now trigger Lambda functions with Amazon MQ. So we have created a out of the box integration between Amazon MQ and Lambda. So you can trigger Lambda functions natively through Amazon MQ, which is another managed service. We have also added integrations between Lambda and Amazon managed Kafka service. And last year, we Event Bridge added support for events from popular SaaS partners, which I touched upon earlier on my previous slide when I showed you how Event Bridge has three different types of buses, right? And API Gateway now supports integrating with both AWS services with your existing on-premises platform through Direct Connect. So if there is a private connectivity that you have already established, then you can use API Gateway to front end some of the services that you have already deployed, possibly on your on-premises environment. And for those who want a hosted workflow offering, we also have now support for Amazon managed workflow for Apache Airflow. So in addition to step functions, which is our native workflow engine, we also now support Amazon managed workflow for Apache Airflow. So any kind of DAG, what we call direct cyclical graphs, if you have such flows, you can deploy those using Apache Airflow product. So that takes us to the last part of the R journey, if you will, the refactoring. So this typically happens when you've been using, or a particular customer has been supporting their application for a long time and they have acquired a lot of technical debt. So the only option for them left with them is to refactor, to now further enhance it and make it more operationally stable, right? So they enter this refactoring phase. So refactoring is all about re-architecting your application, right, to get a specific benefit. So let's start with a common architecture. I think this is an architecture that most of us have seen at many clients and many customers, right? So this is a typical three-tier architecture where you have a web server tier, which is your presentation tier. Then you have your application servers, which are your business logic tier. And then you have your data tier where you store or persist data for long-term usage, right? This is how a typical traditional application would look. A different version of it, how it looks in the modern three-tier application architecture, um, is with a set of technologies that you can bring in, which most of these are, and in this diagram, all of these are pretty much all managed for you. And if you see it for the first time, you might think this is not very different from what you saw on the earlier slide, right? And you are correct to a certain extent. It still looks like it's a three-tiered architecture, but if you look a little closely, you will see that some of the components have been changed. So what we are looking at here is, think of it as a single microservice, and this service performs a specific business function. And many of our customers run dozens, hundreds, of even thousands of such services on our platform with improved scalability and resilience, right? So the integration, as you see here, through the queuing and messaging layer is managed, where each microservice can either exchange messages within itself or amongst other microservices. And most of these microservices are exposed through API layer. So on the left hand side, you see the APIs, which essentially make the exposure of these services for external consumption easier. And then at the bottom of the stack, you see different offerings that we have from a perspective of, if you are having your data in a relational store, then we have Aurora Serverless. If you have a NoSQL kind of a setup, then you would be better benefited by using a DynamoDB, which is our again managed serverless database product. And also, if you store documents, then there is a document DB, which will come in handy. So depending on your particular use case, you will end up choosing either of these or all of these services to build your microservice, right? And that's how you will be able to scale. So all this is well and good, right? So you might be asking a question, Rahul, you have given a overview of all these services. Now, how do I start? Where do I start, right? So what are the things that I need to worry about? What are the guidelines that you as AWS can provide to make this journey easier and fruitful, right? So every decision you make will impact where your time is spent. So when we started this talk today, we talked about some of the reasons why customers consider serverless and how serverless allows the whole agility, performance, cost benefits, right? So modern applications will be categorized along 5 vectors, as you see here on this diagram. So those 5 vectors are architectural patterns, software delivery practices, the data strategy, whether it's a distributed or a fit for purpose database, and operational models, whether it's serverless and automated as much as possible, and the management and governance. So in any organization, you would see that these are the 5 vectors that have a major impact on some of the technology decisions, which then further have an impact on the business strategy, right? So if you have got as an IT unit, if you have got a handle on these 5 vectors, then essentially you make your business's life easier, because then you can give them the agility that they are looking for, right? And be able to create those modern applications as quickly in an agile fashion as possible. So typically you would see that there are two sides to that coin, right? So one of the most important ways that you ensure safety and security, because as we said and as we saw earlier, safety and security is at the center of all this, right? We can't just build an application for the sake of building one which is exposed and is not at all secure, right? That's not what any organization wants. So security is always at the heart of it. So let's look at the philosophical approaches to modern applications, right? One is free for all that you see on the left hand side, and one is very centrally controlled. So those who are working in some maybe larger organizations or even in smaller startups, maybe they don't have that much baggage, but maybe in a larger organization, you might have seen that there is a central IT and then there is application specific teams, right? So there is always this, I won't call it a friction, but there is always this discomfort between application teams wanting to adopt all the agile practices, and they keep complaining saying sometimes central IT doesn't come along or doesn't come to the party, right? And central IT always says agility is well and good, but unless you follow certain best practices, you're not really building or not using the technology to its full potential. So no one actually considers a free for all approach to operations or security, but this is a good representation, right? So typically at AWS, we believe that we can always come up with a best of both worlds, and that's why we have come up with this concept of guardrails, which allows you to do have a win-win, wherein you don't become a bottleneck from a perspective of a central team which wants to enforce the governance practices and the necessary important aspects of securely building applications, but at the same time give a free hand as long as those guardrails are honored to your application teams to quickly develop, right? So this is typically where we think guardrails will come handy, where fast time and low risk to the business will allow you to build quicker, but at the same time build securely. So to that effect, we have launched a product called AWS Proton, which essentially tries to bridge the gap of operator and developer workflow, right? So earlier when I said I was going to touch upon some of the industry buzzwords as of today, microservices, DevOps. So AWS Proton is getting the operator developer workflow, helps you in getting that workflow right. So if you get it right, it becomes easy to have a healthy security and governance and share the best practices without requiring each developer to figure out on their own how to build a secure application, right? Because getting it wrong could be disastrous for your business. So that is why we built Proton. And with Proton, what we typically do is that allows the operations side, the infrastructure operators, to create a set of templates, the guardrails that I talked about, right? So through use of Proton, they can build those guardrails in the form of templates, and they can make those available to your development teams. So the development teams, you can integrate your AWS Proton with your existing CI/CD pipeline that gets your applications and changes into production, right? So it configures the CI/CD pipeline and monitoring, which is a basic minimum requirement, and then allows the developers to hook their applications on top of that. So Proton gives your developers an easy way to deploy their code in a way that enforces architecture and security standards. So you can maintain standards, you can maintain governance, but at the same time provide the agility. So AWS Proton is what actually materializes the guardrails aspect of it, and allows you to allows the development and infrastructure teams their own freedom, but allows them to work together. For most customers, the process of adopting, now we saw different patterns, right? On the previous slides, I walked you through building new applications, replatforming some of your existing applications, and refactoring some of your applications. So across customers, we are seeing a process of adopting a serverless strategy that happens in an incremental fashion. So um, basically, it starts with some developers who discover that Lambda can help them automate some of the basic IT processes, which is what I showed you earlier, the stages of adoption, right? So they just use it for small projects, like let's say creating a cron job or a project that they can start and complete without taking formal permissions. So in their safe space, they try things out, try serverless technologies. Then they start wondering whether what else they can apply to this principle to. And data transformation is one of the next common projects, because that's where most of your applications need to exchange information with each other. And that becomes a little bit of a high profile one, where some of the leadership or some of the leaders in the organization start taking notice of the promise of serverless, of how it can help you build things quicker, right? So they start seeing the benefits of serverless, and that becomes visible to them. So they start becoming your internal champions, who essentially will now take it to the executive level to essentially becoming the voice for all the IT developers, and make sure that they get the right business case created for the adoption to further increase. So typically you will see a curve like this, which essentially starts with certain small experimentation, and then it moves on to the next level, where the larger part of the organization starts taking notice of it, and then you further move into the executive phase, where you have already proven yourself that you are able to deliver projects at pace, and then you start getting more momentum to that. So it becomes like a virtuous cycle, where you show a result to get more work, and it just continues to flow that way. So this is typically how you would see that. So what would be your first steps in the serverless journey, right? So what I would recommend is find your serverless developers today. And then you might think that serverless has not made its way to your organization yet, but some of your colleagues might have already dabbled into this space, might have played around with serverless technologies. Then think of building a small team which is dedicated to evaluating serverless. Ideally, they should be from a cross-functional background. That group represents multiple teams, because that way then the learnings that they have through implementing a serverless based project, they can take those learnings with them and socialize and further evangelize those within their own groups, and then make it the first of tasks of this team to choose a lighthouse project. So lighthouse project is a one that you can showcase, and then you can build upon that, because you can finish it within few sprints, what we call the MVP, right? The minimum viable product. So typically in an iterative fashion, if you're able to show the promise of serverless and able to show how easy and quick it is to deliver using serverless technologies, then that becomes a change agent for you to build upon. So these are some of the things. And one particular pattern that comes in handy is what we call strangler pattern. So some of you who might have already used it may be well aware of it, and we use that on our own amazon.com website when we modernized some of the aspects of our website, right? So this pattern was mainly coined by Martin Fowler, who I think had gone on a vacation to Southeast Asia, where he saw Strangler vines that grow on the trees, right? So as the name suggests, essentially what happens is after a few years, the vines take over the tree, and the biomass is more vine than trees. What that means is you start chipping off from your existing application into a microservices based architecture with APIs front ending the services, and you slowly start migrating over from your existing monolithic application into a microservices world, until such time where you have migrated critical mass over to into your new application, and then you slowly retire your existing application, and then modern application is what is exposed to your customers, right? So typically strangler pattern allows you to achieve that in a phased manner. So you don't have to rip and replace, and you maintain the consistent customer experience. So that's what we call mono to micro. So with that, I've come to the last slide of the day for you. So I've spoken a lot about serverless technologies, different products, how they come in handy at different stages of your journey based on where you are at as far as your journey to the cloud is concerned. So if anything, I want you to take away from today's talk is these 4 themes, right? So our goal is to help you innovate here, right? So we think serverless is the way you can get to the market fastest with the lowest TCO. When we think about where and how to innovate, we do it based on what will most help you to innovate. So we think serverless provides you the most agility through enhanced with new Lambda extensions and the OCI, Open Container Initiative support that I talked about when we talked about replatforming. Performance to meet the broad workloads, which means expanded to 10 GB functions that we have provided support, provision concurrency in Lambda that allows you to reserve certain capacity upfront so that you don't have the challenge of a cold start, and a lowest TCO because you only pay for what you use, right? And we give you millisecond level billing. So essentially, you don't have to keep running an EC2 instance if it's not essentially serving the purpose and only is getting traffic maybe a couple of hours in a day, right? So only the time that you use consume on our platform is when you get billed. And then a complete portfolio. What I mean by that is 140 plus integrations as well as integrations with SaaS products, which allows you to quickly build those modern applications. So I encourage all of you to, after this talk, or maybe if you've already done, go to our website and build a serverless application. The biggest advantage that you get out of it is even if you keep it deployed, of course, barring maybe Kinesis, or if there are some streams that you create or start, you have to be careful about the cost. But if you end up choosing some of the technologies that I talked about, unless there is traffic hitting those services, you won't be paying for it, right? Or you will be paying a minuscule amount. So it allows you to learn quickly, but at the same time, not worry about getting a big bill on your usage, right? So with that, I encourage all of you to go and give it a try, and let us know your feedback, and we'll be happy to come and talk again about specifics of any specific service. If you are interested in that, please provide us the feedback on that. I'll be happy to conduct a little more detailed deep dive session on a specific product or a set of products. If you are using those or thinking of using those, I'll be happy to come and talk about some of those products in more detail with you. So with that, I'm done with what I wanted to talk about today. I think we are at the exact 1 hour mark. So let me uh, gather my breath, and I will stop presenting, and let's go back to see if there are any questions or people are interested in knowing more about what I've talked so far. I hope this
Right.
was
So
helpful.
thanks, Rahul. I mean, this was pretty amazing. A lot of coverage over serverless and how we do serverless with AWS. So by the time you get a chance to go through some of the questions, let me share some of the new stuff that's happening in AWS, so that by then Rahul would have a couple of answers for the questions. There's a lot of questions in the comments, by the way. They're pretty interesting. So do have a look. Um, let's do round two of the slide share again. Let's see now. Here we go. And that's awesome. And I'm able to share my screen now. And it's green in
Great,
color for some
congrats.
reason. That's interesting. Wow. Okay.
StreamYard is somehow
The
not.
new community brand, Francis.
Yeah,
Though
it's a
I
new
think,
community.
yeah, I have a feeling Chrome's not happy with me today. Let me see this. This is just wow. All right. Let me. What we'll do is I'll share a PDF of the slides later on the Meetup group. So oh yeah, now it's working perfect. Yeah, interesting. Okay. That's strange. All right. So the idea is that there's a lot of stuff happening in AWS right now, and everyone tries to keep up. Even we, as whether it's an SA like Rahul or whether it's a developer advocate like me, I mean, trying to keep up with a lot of services, trying to understand what's happening and how much of that you would want to use as your day-to-day workloads is always a task and a chore. So what we wanted to do was, as part of a new initiative, as part of the meetups, and based on feedback from you all, if you are interested to know more about this, is to have a small section every meetup to pinpoint certain announcements and certain community contributions regarding AWS. And the idea is that we want to share stuff that's happening around AWS, right? Whether it is announced from AWS or whether community folks have written articles on it or maybe have built tools. So this is a small a way of just getting started. With that, the first thing I want to do is pretty exciting and related to the serverless talk that Rahul just gave, is that AWS App Runner adds support for VPC. Now, for folks who don't know, AWS App Runner is actually a service that allows you to deploy your source code or your container image directly into AWS and manages everything under the hood, from deployments with the deployment pipelines all the way to the networking to the load balancers. And you just pay for the compute that's being used behind the scenes. So how the amount of time that your container is being run. It's now just available in a few regions. But if you are someone who's been using App Runner, you would know that when App Runner was launched, it only supported connecting with the resources that are public. So if you had a database, for example, you would need to make your database public for it to work. But now we have VPC connectivity, which is pretty awesome. And the way it works is that you can point it to your custom VPC, and you can select your VPC settings and the security groups that are needed. And now your container, your app within the container, can communicate with any resource which is in a VPC. So this could be think databases, it could be another container service that's running over there. So think microservices, think all of that. So now you're one step closer to actually deploying faster to AWS with your container images. And all you need to do is just connect it through the VPC. So there's a QR code over there if you want to learn more, if you're able to scan, or you can look at the video later and then just go to the link and have a look at that. So this is with what's happening with AWS. There are a lot of other announcements, but I thought, okay, for serverless, this makes a lot of sense. Next up is community contributions. And first, I wanted to just highlight Muhammad's article on how he used SQS on e-commerce delivery for a certain integration that he was working on. Pretty interesting article. If you're someone who's new to the serverless space, if you're someone who's new to event-driven architecture, I would suggest you have a look at his article. He talks about how a project that he was working on, and maybe is still working on, is where he had to actually integrate an e-commerce platform with a third-party delivery service, right, a downstream service, and how he actually converted it into an event-driven system using SQS so that it could handle a certain amount of loads and requests per hour. And this actually is in production, and is something that's going on right now. And there were a lot of criteria that were around this to actually choose this architecture. This article is a very good way to actually, for you to understand, if you get a certain business requirement, how you would translate that into an actual architecture. So he walks through some of the decision points that he made and designed. So definitely have a look at this article. Pretty good. Next up, we have another one that is by Salvatore, and he's in Europe. And what he does is he actually talks about 4 ways to improve your AWS Lambda. Now, a lot of folks may have started using Lambda just as a way to deploy a function and just to have that request being run. But now, when you start going further down, you want to make sure that you're able to handle some best practices. I believe there was one question on best practices for migration. This is for best practices of how to just use Lambda. And what you need to do is you just need to keep a couple of things in mind. So these are some recommendations he has. First one is to keep the variable outside the handler, for example. The other one is on understanding the power of layers. So layers is a concept where you have lambdas that could have a shared package, a shared piece of code that you could have in a lambda layer that could then be accessed by multiple lambdas. Then you could also inspect your code with X-ray. So this is very useful when you want to do tracing across multiple lambdas or multiple services that are being called. This allows you to then find out if there's any hotspots, if there's any hiccups that are happening, how much time it takes for each request call to happen. And pretty useful way to actually get started with distributed tracing, because one of the challenges you'll see when you actually go to a microservices architecture is that it's not one stack you need to manage, it's multiple stacks, right? And so you need to also make sure that you're able to look at the logs at the same time. And the last recommendation he gives is about balancing the RAM accordingly. And this is tied directly into when you configure your Lambda, because in Lambda you can choose the RAM that is needed, which will then decide how much GB CPU is actually added how much CPU power is actually added to your Lambda to execute. So pretty interesting recommendations. He also recommends a tool that's available over there that gives you a costing of sorts, an estimate of costs on the Lambda. So have a look at his article also. This will also give you an idea of how you can get started with Lambda and improve it better. So that's it for what's new on AWS, and I'm happy to hear feedback later in the comments. If you're interested to know more about this, we will add more announcements later on this. I'll just stop my screen, and it worked. Awesome. Over to you, Rahul.
Thanks, Faz. That was really informative. Yes. And some of these services are very critical when it comes to managing distributed applications, as you said, because one is the flexibility microservices provides to you, but at the same time, it comes with its own challenges, right? So having these tools at your disposal really is a important thing. So I've got a chance to go through some of the questions. Let me answer those. So I think, and I'm not sure because these are handles, so maybe I'm not pronouncing the names correctly. So please, I apologize in advance. And some of the cases, I'm not sure who the user is, but I'll just read the question and I'll answer it. So one of the questions was, is the cost inversely proportional to the level management by us? Meaning Lambda at the top with low management cost higher relative to EC2 self-managed. So to answer it most succinctly, it's not exactly whether you would save a lot of money on Lambda versus you would not save a lot of money on EC2. What I mean by that is when you are managing things by your own, there are a lot of hidden costs when perspective of managing things, patching servers, which essentially you might not be able to put a number against every time, right? So running things and managing things on your own can become a one financially not viable issue. Also dependency on people who have to have that specialized knowledge to be available, and also not able to keep up with the advance in the technology, right? So with serverless, what happens is because we support pretty much a lot of runtimes that you can quickly build on, the opportunity cost of not able to do it if you're managing everything on your own, unfortunately you cannot put a number against that, right? So there is no immediate benefit or a cost benefit analysis that you can do that way. But yes, absolutely, depending on the application that you are running on EC2, if you want to migrate over to Lambda, there are cost comparison charts that we can share with you, which will help you come up with your own analysis of what those numbers would look like, right? So for example, if you're running a mail server which has to run 24/7, there is no point in making it a serverless application, right? So there are specific use cases that are really good candidates for thinking serverless, but there are some which you essentially cannot avoid. Then I think the other question was around, I'm just scrolling through this. There was one question for link to app flow, which I think we've already shared. Is there a way to run part of the serverless on local for dev purposes? And that's a very good question. By example, running Lambda somehow locally. So one of the things that I guess maybe for another session I can bring in and talk in more detail is a framework called SAM, Serverless Application Model. I'm not sure how many of you have already used it. And also there is one more product that we have called CDK, Cloud Development Kit, right? So these are a couple of options that are at your disposal to essentially locally develop your code as if you're doing a local development, test it out. And as you can imagine, what it does is it spins up a container in the background, packages your function code inside that container, and allows you to test locally before you deploy. So it comes with its own set of templates and a set of guidelines on how you should be creating that structure. And it also allows, it also provides you with command line utilities, which you can essentially run on your own laptops or your machines and test it locally before you promote it into the cloud, right? So you don't have to actually use our UI to build your Lambda functions. You can use your own Visual Studio Code or your own IDEs for building your code, and essentially in a declarative fashion, create a structure or a template which essentially runs first locally on your machine, which you can test, And then once you are confident that it is doing what it is supposed to do, you can deploy it using the same tooling. So SAM is one such framework which is highly encouraged for serverless development. CDK takes it one level further, where through use of constructs, which are pre-packaged components, which you can put together and create serverless applications quickly that way. So if there is interest, maybe we can have another session on CDK and SAM specifically, where I can come in and walk in more details about how the local development can happen. Then I think there was one more question by Harshprit on any suggestions for best practices for optimizing the cost for Lambda functions. So first and foremost, anybody who is building in cloud, I think appreciates the fact that it's a journey, right? It's again not done and moved on to something else, right? So when you build an application, whether it's serverless or not, you have to monitor it closely. You have to look at the usage, and we provide a lot of other surrounding services that allows you the visibility into your usage on how your particular service is being used month over month, week over week, with certain projections on how your trends are looking like from a costing perspective. So just because you created a serverless application doesn't mean you're absolved of all costs. You have to keep a check on your usage as well. But there are tools and technologies and products available on our website. I'll share some of those links here as well, where you can keep a tab on some of the consumption aspects, right? The advantage is because we give you a very granular view into your consumption, you are much better informed and you are much better off when it comes to understanding your real usage. So there are best practices, and I'll again share some of those links offline on how to optimize. One of those things could be through tracing. One of those things could tracing mainly is used mainly for performance bottleneck and trying to figure out whether your application is running optimally. But at the same time, because you have traced it all the way, you get a good view of what all calls are happening. So if it's a very chatty set of application, then you can further improve it. So there are ways to manage your cost, and CloudWatch monitoring helps there, which is very well integrated with most of the services. So yeah, there are multiple things at your disposal which you can benefit from when it comes to managing and optimizing cost further. Okay, are there any other questions? Is there a way to validate Lambda code locally? I think I answered that through SAM and CDK. Muhammad had asked that question. I hope I have answered that already, or maybe ask a new question. Will you recommend to use AWS CDK with serverless, or should we use SAM? So this is where I think there is no clear-cut answer, as you can imagine. SAM makes you learn a particular way of building serverless applications, and it creates an abstraction on top of CloudFormation. But those people who are more comfortable with the operations side of it, who are very well very well versed with declarative programming, as we say, from a perspective of just declaring what you want and not worrying about how it is deployed. They just are focused on the what part of it, are very happy with what SAM provides them, because SAM creates an abstraction, but it creates a lot of other constructs behind the scene when you build the SAM template. CDK is helpful for people who come from a programming background and who are very much familiar with or comfortable writing code, be it Python code, be it TypeScript code like JavaScript code or Java code. So those who come from a programming background, so as you can imagine, the developers here can write the infrastructure as code, right? So it becomes an imperative style of programming wherein you don't just declare, but you also write, but using a language that you are familiar with. So with CDK, what you get is that feature wherein a developer is more comfortable not just writing his business logic, but also writing the constructs which allows him to deploy the infrastructure along with his code. So he can package his code as well as the infrastructure code together as one unit and deploy it using CDK. SAM does the same, but in a different way, where you have to do a lot of declarative programming along with your code. So depending on the comfort of the team that is building it, and again, maybe like I said, in another session we can go deep into each of those and look at the pros and cons of each of those, right? So, but it all depends on what your team is comfortable with, I guess, at the end of the day. I hope I answered that question. Yeah, with that, I think we have. I at least don't see any other questions there. So, yeah. So back to you, Faz and Anas.
Yep. Thanks, Rahul. It's interesting. I mean, there's a lot of asks on different ways and approaches of doing serverless. So do definitely keep your feedback coming. I mean, we have the Meetup group, we
Sure.
have the LinkedIn group also. And if you think that you want to have a more deep dive session, Rahul's also mentioned that he can cover certain aspects. What helps is your feedback because it then allows us
Absolutely.
to understand what's the kind of topics you want, whether you want something which is more hands-on. Would you be interested in participating in a workshop, for example, right? So maybe as
Yes.
a community workshop, we could run something either on a weekday or a weekend online, right? So just for you to get started with serverless, for example. These are things that really help us. So feel free to provide your feedback on the content and what you want to learn next, and also share your experiences, right? So maybe some of you have started with serverless and you're using it in your company, in your projects, maybe freelancing projects or anything else, and what are the challenges you've faced, right? And how you would want to learn something specific to address those challenges. So yeah, feel free to provide your this one. I think there is one question that's come in. What's that? Yeah, .NET is slower. So a lot
So
of questions on that. Yeah, also.
yeah, sure, no problem. So I'll take that. So again, this is not a apples to apples comparison. Unfortunately, just because you are using a particular framework doesn't mean it's slow or fast. It all again depends on the complexity of it, right? So if you write a 1,000-line .NET code and try and package it inside a Lambda function, naturally it won't um, perform as better as Node.js. But as a framework, they are very different and they serve a very different purpose. There are optimizations that we have done as far as the execution environment is concerned, but at the end of the day, you have to understand the cold start problem is because when the first call comes in for a Lambda function, the Lambda service in the background has to first take the runtime environment, put it or install it on the execution environment actually, then take your code, deploy it on that same execution environment and make it ready before it can be invoked, right? So cold start problem can be addressed by using what we call the provisioned concurrency, right? Wherein we try and keep a warm pool of some of these ready to go functions, which means the runtime and everything is already installed and ready to go with the function already deployed on top of it, but ready to be invoked. But you have to again use it judiciously because if you use a lot of provision concurrency, then you can imagine it'll come up with some cost, right? So it's not going to be free. So there are ways to make it perform, but it's not a blanket .NET versus Node.js one over the other, which has a better way. There are again ways to create global variables where some of the environment variables can be declared once, so they don't have to run every time. There are ways to externalize your environment variables into something like a secrets manager where you keep some of those to be accessed at a later point in time. So you save the cycles on what code has to execute before your function is ready to be invoked, right? So there are ways to optimize it further. And again, in a maybe another deep dive, I can talk about some of those optimization options that are at your disposal.
And just to add to that, as a developer, it's also very dependent on the kind of code you write, right? So how you initialize your variables is one thing Rahul has mentioned. How you actually write the code. If you're loading a lot of libraries in the beginning, you would want to make sure
Correct.
that if there's a way to actually put that in, like let's say a Lambda layer. That's one of the articles that I shared right now. Someone from the community shared that. We have best practices also mentioned here, and definitely we can have a session in the future if there's feedback on that. So I guess let's call it a day and wrap this up. I think it's great to have Rahul come in and share about serverless and just get the whole ball started. If anything, I have a feeling 2022 is going to be a serverless year for all of us. Everyone wants to know more about how you can get started. So feel free to provide feedback on LinkedIn, on YouTube, and reach out to us. Feel free to let us know what you want to learn next. And if you're someone who wants to share and you want to speak in subsequent meetups, let us know. And you can come in and share the stage with folks like Rahul, right, and share about your experiences
Absolutely.
and how you've built stuff. And that's pretty awesome. I mean, at AWS, we love hearing our customers. We love hearing what you are building. So feel free to reach out if you're interested to speak. And with that, we'll call it a day. Have a safe evening, everyone, and we'll meet you in the next meetup.
Thank you, guys, and thank you for joining us, and thanks for this opportunity for us to share some of the serverless technologies with you. Looking forward for more such collaboration.
Thank you, Rahul. Thank you, Faz. Thank you, everyone, for joining us tonight.
Thank you.
See you again
Thanks.
soon.
Everyone have a good
See you
evening.
guys.
Bye.